I'm gonna.
Cool. I'll share my screen and someone can let me know that it's actually sharing properly. I can go ahead and start. Can you
That's
guys see
good.
the slides?
Yep.
Awesome. Yeah, so this chapter is all about writing tests. And as we've already discussed a little bit, Rust, or at least Cargo, provides a lot of native tooling around writing tests, unit tests, integration, benchmarking, and stuff like that. So just diving straight into it, we're gonna talk about how to understanding how to write tests in Rust, learn sort of the anatomy of a test function and test modules within Rust. Check out different macros like assert equals, assert not equals. Check out for expected panics using the should panic. And then learn how to kind of control the test execution environment with different command line flags, and discuss how to organize tests. And it's pretty cool. Rust has, I guess, some what would you call it? Opinionated way for how they separate unit tests and integration tests, which makes a lot of sense. And it's pretty interesting. So we'll hop into that a bit as well. Yeah. So I guess just a bit on unit testing in general, which I'm sure most of us are pretty familiar with. But tests, ensure the code functions as we expect. Rust, or at least Cargo, provides native support for automating tests within Rust. There's different types of test that are kind of supported within Rust. So you have, unit tests and integration tests, but there's also automated documentation tests that'll actually run the examples within your library docs. And you can also automate benchmarking, which we won't get into too much this chapter, but just to be aware of. So just talking about the typical structure or flow of writing tests. So we kind of start off, we want to set up any needed data or state for the test. We're going to run the code that we actually want to test. We're going to assert that the results are, what we expect or don't expect. Yeah, and that's essentially the structure of a test. So if we look at that in a Rust test function, basically test functions are just the same as any other Rust function. They're just annotated with this, oh my goodness, I forgot the freaking terminology for this. They're annotated with hashtag test. I can't believe I forgot what that's called.
Attribute?
That's
Attribute?
what I was gonna suggest too, but
Yeah,
I'm not confident.
Derive the trait, or anyways, I can't remember now, but
I thought
anyway.
it might have been directive, but I might be wrong.
Directive. Well, okay, at least none of us remember, so I don't feel so bad anymore. Maybe probably one of us said. Anyways, we flagged this kind of
Attributes verified.
attributes. Okay, awesome. Yeah. This test attribute ahead of the actual function definition. And this will let Rust know that that this is a test and this is expected to run when you run cargo tests from the command line. So just having a quick look at some code, and I hope that's big enough to actually see what's going on.
It is.
If we look, oops. If we look here, we have this kind of really simple function that just adds the left and the right. And you can test, for example, sorry, I've kind of done a lot of this example within this code. So for the first check right here is a pretty simple assertion that 2 + 2 = 4. And if I run specifically that test, I can see that both of these tests pass. So the function kind of works as expected. I had to specify only to run add here because I have actually quite a lot of different modules in this crate. So the assert macro is super useful. Well, is pretty fundamental for writing tests. It should be relatively familiar coming from an R background. It basically just asserts that the condition evaluates to true within the actual function argument. So there's another example here, right? We have I'll show the code in a second, but let's say we define this kind of larger rectangle object with a width of 8 and a height of 7, and a smaller rectangle with a width of 5 and a height of 1. If we call the can hold method on the larger with the smaller passed to it, we expect that the smaller should be able to be held within the larger. And as we'll see, this can hold function returns a Boolean, so it's kind of a perfect well, it's a suitable function to pass into this assert macro. So if we look over here, the can hold example. So here we're defining this struct called rectangle that just has two unsigned 32 again, I'm forgetting terminology, traits, I guess, whatever, width and height. And then we implement this method for rectangle called can hold, which basically checks that the self width is greater than the other width and the self height is greater than the other height. If both of those evaluate to true, this whole function evaluates to true and returns a Boolean. And we can see here, we run this test against the example that was just given. And if I run just that, I think I can even do there. We can see that the test can hold, larger can hold smaller, passes with this okay right here, and all the tests passed. Yeah. So that's the kind of vanilla assert macro. There's also some kind of assert equals and assert not equals macros that basically assert equals checks that the left and right evaluate to each other. Assert not equals makes sure that they don't evaluate to each other. And they provide more detailed error messages on failure. Yeah. So we can also add custom failure messages. So this is especially useful if we want to have more information than just the fact that a test failed. So for example, we might only get, if greeting contains name fails, it might only say that this test fails and we have no idea actually why. So to sort of help future selves for debugging, we can pass a much more descriptive custom message to this assert macro to print when the tests don't pass as expected. So having a look at this example, we can see, so going through the book, normally we would expect that this greeting function concatenates the name argument with this hello string. So we would expect that greeting passed with the argument Carol would return hello Carol. And we've purposefully coded it with a bug here where it's just saying hello and it's not actually even using this name argument at all. So running this test, if we add this custom error message, greeting did not contain name, value was, and then we pass it what result is, we can get a much more descriptive explanation of what actually goes wrong here. So if I run the test, we can see here the custom error message, greeting did not contain name, value was hello. And that can give us a lot more information when we're trying to sort of debug things in the future. Alrighty. Yeah. The next kind of interesting thing is this should panic attribute. And this is how we tell Rust that, you know, within this test, we expect that the code in this function is going to panic. And we can even well, it's good practice actually to specify a substring of the panic message, because of course you can have panics for many, many different reasons, and you want to make sure that if you say you expect a panic, that you're expecting the panic that you actually expect, and not some other completely unrelated issue. So you do this by within the should panic attribute, you pass it this expected argument with a substring of the panic message, and that'll match against whatever the message is that's in this should panic, or sorry, whatever the actual panic message is that's a result of this function. I think I have an example of this one as well, but I can't remember. Yeah, so for example here, right, this is a bit harder to see when it's so small. So we have this guess function that sort of checks against well, panics in two different ways depending on what value is given. So if you give a value less than 1, it says the guess value must be greater than or equal to 1, got whatever. And if the value is greater than 100, it says guess value should be less than or equal to 100, but got value whatever.
Could I ask a question real quickly? Do you know if does this? I guess the answer is staring me right in the face. So it matches on a substring, basically. What I was trying to find out.
Yeah, exactly.
Okay. But never mind.
No worries. Yeah, so he's less than or equal to 100, you know, is a substring here of the actual panic message that we expect with this should panic attribute here. So if I run this one, ignoring this because it's just some warning about dead code, we see that the should panic expectation passes. And we can see maybe also, you know, if we change this, and try to run the same thing, that's good. Sorry, all I've done here is change the expectation to not actually match this substring, and now this test here fails as expected.
By the way,
yeah.
this terminal emulator you're using, I don't think I've seen this one before.
Oh, yeah, this is Western. It's fun.
Yeah, looks good.
Thank you. I can send my doc files in the Slack channel. Yeah, so that's pretty cool. And nice to have these expectations, because if you're just saying you expect something should panic, it's not really precise enough to actually well, you could be introducing bugs by just saying, you know, this should panic, and I don't really know why. This is also pretty interesting. So far, all of the tests that we've talked about have sort of failed on panic. But you can also use the sort of the result enum that's idiomatic in Rust. And this allows the use of the question mark operator within tests. Which is kind of interesting. Yeah, okay, sorry. So the next step, now we're going to talk a little bit about how this previously we were just talking about actually writing tests. This is going to dive a bit deeper into controlling how the tests are then actually run. So by default, every test is run in parallel in a separate thread. So to however many threads can be spun up at a time, for example. If for some reason you need tests to run consecutively, for example, it could be the case that each of the tests share state, and running them in parallel could cause issues. You can set that using this by setting this test threads flags equal to 1. So if I run cargo test, barring these warnings, it's gonna run these 5 tests in parallel. If I run, what was it, cargo test like this, it'll take a little bit longer, but it'll run all of the tests in a single thread.
I totally noticed that took way longer.
Yeah, so much longer for all of these incredibly small Rust functions. Yeah, fair enough. But cool to know that if for some reason you do need it to run in a single thread, it's possible to set that. You can also you can also display the output of functions even for passing tests. So for example, maybe you want some logging information or some of these println outputs. And so to show all outputs from a function, you pass this show output flag, which is pretty straightforward. I don't think I have an example for that actually, but let's see. Yeah, nothing really interesting because we expected this to show up anyways because the test was failing. Yeah, so something I've already kind of been doing implicitly in the whole discussion is you can run single tests by specifying their name, and you can also run multiple tests by specifying a pattern that matches against the multiple tests. So if we look here, if I want to run all tests, I just type cargo test, and it's going to run the add tests, the can hold tests, the guess greeting. If I only want to run, for example, the tests on add, I just type cargo test add. It'll match against the add test name and then run the 2 tests that I have written under that submodule. And for example, to show the pattern matching, if I wanted to, for some reason, run only the greeting and the guess tests, I could do cargo test G, and that'll run. Oh, that's interesting. Runs guests, greeting, and also larger can hold smaller because larger has a G in it, which is interesting. So it's not just the module name, I guess, but also the actual name of the test itself. You can imagine in much larger scale projects, if you're kind of precise with your naming conventions, that you can test different components of the project based on a prefix that's shared across multiple functions. Yeah, so there's obviously use cases for that, and it's pretty cool to have it not just to be able to specify it in a more flexible way and just match against a subset of tests that you want to run at the same time. It's quite powerful. You can also, for example, if you have a particularly large or expensive test, or one that takes a really, really long time to run, you could ignore that by default. So for example, this wouldn't necessarily run in your sort of day-to-day development workflow, or maybe wouldn't run on CI or things like that. But you can then with this ignored flag choose to run these ignored expensive tests. And so that's a nice way to if you're building this very large computationally expensive test, you can just run it explicitly when you choose to run it, which is cool. Yeah, so for test organization, this is where Rust's distinction between unit testing and integration testing comes into play. Sorry, not to suggest that Rust is where the distinction between unit tests and integration tests came from, but they do yeah, neatly bucket kind of those two different concepts. Within the unit test paradigm or world, these are tests for individual, relatively small units of code in isolation. And they're often found in the same file as the code that is testing is defined. So these are by convention found in a module called tests that has this config test attribute specified ahead of it. And then we have to run this use super glob or use super and specify whichever functions you want to pull in from the parent module, because this test module operates under the exact same conditions as any other module in Rust would operate under. And then we specify the test attribute as usual and run the tests. For example, if we didn't dump the unit tests in this test module and just have this function sort of in the main body of the file, that would be totally fine and that would run and there wouldn't be a functional problem with that. But the interesting part about the config test attribute is that it ensures that the testing code isn't actually compiled into your source code, and it's only compiled when running tests. And so that's useful to keep your binary sizes small and to prevent unnecessary bloat on your compiled code. Does that make sense for everyone?
Also compile time too, I presume.
Yeah, sure. Compile time as well. Awesome. So that's sort of the unit test kind of topics. Also a note on private functions. You can test private functions in Rust. There's definitely, I mean, I'm not familiar with them, but there are definitely some languages where you cannot test private functions. And I know that there's discussion around whether you should or should not be able to test private functions, but in Rust you can. And that's because there's no, as I said before, this tests module this operates under the same rules as any other module in Rust. In particular, because it's a sub-module of the module where this function is defined in, it has access to it even if it is private, right? So if we pull this in using this glob operator, even though we haven't specified this function as public, because this is a child module of where this is defined, it can access it and it can test it as anything else. So that's just maybe a note for other people coming from
Jackson
different languages. Yep.
So that works as long as you have it in the file in the same file, right? So you couldn't have a test like in a separate test directory that would reference something internal that's not public.
It would have correct. I mean, it would have to. You could have it under a module directory, I believe, as long as it was underneath the parent library file. Like it's the same logic and rules as any private function would follow, basically. Yeah.
Thank you.
No worries. Yeah. So then we go to integration tests a little bit. So talking about unit tests before, unit tests are testing all of the internal guts of your program, every potentially internal function that each step sort of operates as you expect. Integration tests are more about testing the public API as an external user would. So when you're writing integration tests, you sort of imagine you don't have access to anything other than the public API of your program, and write your tests as though you're a user, exploring that program. So in Rust, these tests are then placed in the actual tests directory of your project, and each file in that directory is going to be a separate crate. And you still use, you still write kind of test functions as we did in the unit test case. You use this attribute, you use your assertion functions, but essentially every integration test should have sort of like a namespace function like this, essentially calling the public API of your program. So you're not going to be testing internal functions or private functions in these types of tests, but only the exported external API. Does that distinction make sense?
Yeah, absolutely. I mean, I think that's one of the cool things, that things in the test directory can only use the public API, which is great because that's exactly what you want to test in integration, right? You want to make sure that the public API works as advertised, right?
Yeah, totally.
That includes not being able to get at private functions and such, right?
Yeah, true. Which I guess you could test with a should panic. Anyway, with the should panic attribute. But yeah, it's nice that the distinction is made for us, and the style for how to do it is already sort of opinionatedly defined.
You may get to this, but is this somewhere you would test how it works with some other packages as well? Would you pull something else into that example and see how does my package work with some other structure?
So that's exactly a question I had, actually, because that's usually how I think of integration tests. But then I guess if you don't have direct control over the other package that you're testing, it probably wouldn't be an integration test. Like if it's dependent
But
on
if you
potentially
assume the other package is working correctly, does my package work with that?
Yeah, exactly. I don't know what's idiosyncratic here. I would imagine you could add some type of actual integration test, in the sense of how does the public API of my crate integrate with the public API of another crate. I would expect it makes sense to add something like that here. But I'm not sure if that's like necessarily Rustation gospel, if that makes sense.
I might have a look through some crates and see if I can find someone else using the test directory and see what they're putting in there. I'll put it in Slack if I can find anything.
Awesome. Thank you. Another interesting point is that it's common to, or you can design some submodules and integration tests. And this is especially interesting if there's setup code that you want to share across all of your tests. So for example, if you have some data-oriented testing infrastructure and you want to mock some data sets, you might want to do that in a common module, so that every test and every thread can benefit from that shared setup code or mocked data. So you do that by for example, doesn't have to be exactly like this, but you can define this common module. You can define your setup code in there, make it public, and then pull that module into your integration tests. And then call that setup from within your unit tests. So that's a nice kind of style for reusing code and not redefining the same setup information every time you run a test. One note, which kind of makes sense, binary crates, so those that only have main.rs can't be tested directly via integration tests. Basically, the solution there is to extract as much logic as possible into the library crate. I think that we're going to go into that a little bit more, potentially even in the next chapter. But it's pretty common for the main.rs in a binary crate to really only have configuration and some call function, and for all of the logic to then exist, or all of the actual business logic to exist in this library crate. And in that workflow, you can then just define all your tests on that library crate as normal. Yeah, so that's pretty much it. I kind of blazed through that a little bit because it's not super dissimilar from what folks are probably somewhat familiar with already with R. It's just nice that all of this is already sort of, you know, batteries included with cargo, and kind of comes with some nice opinions and nice support already from the get-go. Yeah, so I'm gonna stop sharing my screen if I can. As I said, I didn't actually get into